Okay, welcome back. So what we want to do now is just apply what we just learned about the new reciprocal ratios and try and come up with some equivalent statements to some existing ratios we've already seen. So for example, if you see the fact that sine theta is equal to 2 over 3, what does that mean in terms of a reciprocal ratio? Well, again, the reciprocal ratio to sine theta is going to be cosecant theta. So if sine theta is equal to 2 over 3, that means cosecant theta is equal to 3 over 2. Again, just taking the reciprocal of that ratio. One thing I want to note here, remember it's the ratio that you take the reciprocal of, not the angle. The angle is still the same inside the triangle, just the ratio is just going to be flipped. Okay, so for example, if you have secant theta equals 11 over 7, okay, well, secant is a reciprocal of cosine, so the equivalent statement would be the fact that cosine theta will be equal to 7 over 11 instead of 11 over 7. Okay, that would be how we move between having a primary ratio and its reciprocal ratio, or vice versa. Okay, so let's try and apply this to some simple calculations you've done before in the past. So something like tan 75, you can do very, very quickly in your calculator. You're going to sub that in very, very quickly, and you'll hopefully quickly see that tan of 75 degrees is 3.732 approximately to 3 decimal places. When you get into a situation for cosecant, it's a little bit more complicated. Again, there is no cosecant button on your calculator. So if you want to evaluate this, you have to first express this in terms of a primary ratio that you do know. So cosecant is the reciprocal of the sine ratio. So we can rewrite this as 1 over the sine of 64 degrees. And again, I want to point this out again. It's not the angle that you take the reciprocal of, it is the entire ratio you take the reciprocal of. So sine of 64 you can find out on your calculator. So you go 1 divided by sine of 64, and you should get approximately 1.113. Okay. If you're not having trouble getting this in your calculator, come see me or ask someone else, and I can show you how it works in your calculator. But it's really important you get used to using your calculator, so you can work around certain situations like this. So I want you to very quickly try secant of 74 degrees. Okay, make sure you can get this answer of 3.628. Okay, hopefully that worked. If it didn't, remember that secant is a reciprocal of cosine. This will be 1 over the cosine of 74 degrees. So 1 divided by cos of 74 degrees should be 3.628 approximately. Okay, so that's just evaluating ratios, some of them with reciprocal ratios in there. Now let's think about solving for angles involving reciprocal ratios. So again, this first one right here, if you have sine theta equals 0.84, you would have done tons of problems like that back in grade 10. You know, to solve for theta, you take the sine inverse of each side of the equations. You get the sine inverse of 0.84, which you run through your calculator should give you to 1 decimal place about 57.1 degrees. Okay, so again, now with the reciprocal ratio it becomes a bit more complicated. So remember, we can't take the secant inverse. I mean, really, that is what we're trying to do, but we can't do that because we don't have a secant evaluation on our calculator. So what we need to do with secant is turn it into cosine. Okay, so again, if we want to change it from secant to cosine, remember that secant is equal to 1 over cosine of theta. So 1 over cosine theta will equal to 1.6243. Notice I haven't flipped the other side yet because, again, I haven't actually changed anything. Secant theta is equal to 1 over cosine theta. So now if I want to have just cosine theta by itself, say 1 over cosine theta, I can take the reciprocal of this, so I have cosine theta over 1. But if I take the reciprocal of one side of the equation, like I did here, I take the reciprocal of the other side as well. So this is 1.6243 over 1. So the reciprocal will be 1 over 1.6243. Okay, now in practice you can probably very easily skip this middle step, go straight from secant theta equals 1.6243 to cosine theta equals 1 over 1.6243. But I just wanted to show where that came from. Okay, it's not necessary to do that step though. So in this situation now, you have cosine theta, a ratio that you can evaluate in your calculator, equal to 1 over 1.6243. Okay, so theta will be equal to the inverse cosine of 1 over 1.6243. Okay, so run that through your calculator. Make sure you get the correct answer of about 52 degrees. Okay, and last but not least, try the third one on your own to make sure you can get it to work. You should get an answer of about 53.1 degrees. Okay, so if you want to convert this to a primary ratio, cotan is the reciprocal of tangent. So take the reciprocal of the ratio to get 4 over 3, and cotan theta, the reciprocal is tan theta, and then you can solve using the tan inverse. Okay, so last thing I want to do is work on evaluating expressions exactly. So I want you to put your calculators away for this one. You shouldn't need them. Okay, so what I want you to notice here, if you look at the angles involved, 30 degrees, 45 degrees, 60 degrees, those angles all come from the special triangles I showed you guys a couple slides ago. So you should be able to replicate these calculators. You shouldn't have to look back at your chart for anything. So remember, how do we draw these triangles? So one triangle is an isosceles triangle with 45 degree angles in it. And I don't expect you to have these memorized right now. I mean, we are just getting started, but do try to remember these triangles. Put your calculator away, put the chart away. Just try and be able to generate these and try and get the ratios from there. And in this, we have side lengths of 1, 1, and using the Pythagorean theorem, this becomes root 2. Okay, the other triangle that you looked at has angles of 30 degrees, 60 degrees, and 90 degrees in it, and has side lengths of 1, 2, and root 3. So from here, you should be able to get all the ratios you need to solve this. So for example, for the cotan of 30, okay, we know that the cotan of 30, well, first of all, cotan of 30 is just the reciprocal of tan of 30. So if tan of 30 degrees, looking right at this triangle, is going to be opposite over adjacent, so it's going to be 1 over root 3. Then cotan of 30 is going to be the reciprocal of that. And the reciprocal is going to be adjacent over opposite, which is going to be root 3 over 1, which of course reduces down to root 3. So the cotan of 30 degrees should be equal to root 3. And notice we were able to calculate that without actually using our calculator at all. Okay, so again, that's not too bad. Again, once we have these triangles drawn out, we just need to be able to evaluate these ratios. So I'd like you to try the second one on your own. Try and figure out the cosine of 45 degrees times the cosecant of 60 degrees. When you're finished, push play, we'll go through it together, and that'll be it for the lesson. Okay, so your final answer should be 2 divided by root 6. See how we got to it? Let's take a look at cosine of 45 degrees first. So for 45 degrees, cosine of 45 will be adjacent over hypotenuse, so 1 over root 2. Okay, so that part's done. Now for cosecant of 60, what I can do is I can first figure out what sine of 60 is. Because remember, sine of 60 would be the reciprocal. Okay, so using my special triangle here, sine of 60 degrees will be equal to opposite root 3 over hypotenuse 2. So it's going to be root 3 over 2, which means the cosecant of 60 degrees should be the reciprocal of that, which should be 2 over root 3. Okay, so cosecant of 60 degrees should be 2 over root 3. Okay, from there it's just a matter of simplifying, multiplying my fractions. So a numerator, 1 times 2 is 2. For my denominator, root 2 times root 3 is root 6. Okay, so that's it, that's all. There's your homework. Make sure you practice using the special triangles, being able to work with reciprocal ratios, and then we'll be set to move forward.